I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Picking up some dust.
In the 1960s, an impossible dream came true when human beings walked on another world.
The Eagle has landed.
In all, 24 Americans went to the moon. But it took an unseen army of over 400,000 engineers and technicians to make it possible. This is the story of the men and women who built the machines that took us to the moon. November 16, 1963. President John F. Kennedy visits NASA's launch pads at Cape Canaveral. But while the president was focused on landing a man on the moon, his chief rocket designer, Wernher von Braun, was already thinking about what the astronauts would do once they got there.
Wernher von Braun had dreams. He was very vocal. He certainly popularized the whole notion of space. And so he not only was the technical expert in the big rockets, he was the inspiration for a lot of the things that followed.
Dr. von Braun was looking toward the future, setting up lunar bases on the moon, doing an extensive exploration program of the moon.
For von Braun, the moon was not just a target to be reached, it was a world to be explored. But he knew an astronaut wouldn't be able to go very far on foot. So von Braun called for a lunar vehicle to allow astronauts to range freely across the moon's surface. Auto engineers like Sam Romano were quick to respond.
There were quite a few people interested, quite a few companies interested. My feeling then, I was working for General Motors, and they were very good to me. They had a very nice environment to work in. So I said, my goodness, if there's going to be a vehicle on the moon, it's going to be a General Motors vehicle, and I'm going to make sure that happens.
Across America, engineering companies rose to von Braun's challenge with a variety of designs. Some looked more like farm equipment than space hardware.
The wheels sometimes range from 5 or 6 foot tall up to 10 or 12 foot tall. Different wheel designs, as well as different cab designs, but it basically gave the people a kind of a belief that you could indeed put together systems and have mobility on the moon.
But the truth was, that confidence was not well grounded, because no one really knew what the surface of the moon was like, and many suspected that it wouldn't be a surface you could easily drive across with wheels. A fact that Sam Romano's colleague, Ferenc Pavliks, was only too aware of.
There were some scientists who postulated that the moon is covered with a thick layer of very loose, dust-like material. So anything you put on it is going to sink.
In the absence of any hard facts about the lunar surface, Sam and Ferenc began experimenting in their lab.
When you do some experiments with locomotion in terrain that you're unfamiliar with, you usually develop it in something called a soil bin. Now, a soil bin is to vehicle engineers what a wind tunnel is to aeronautical engineers.
We came up with vehicle concepts of the wheel type, track-laying vehicles like tanks. We even looked at an Archimedean screw in case everything's submerged under the surface, it can borrow itself through the loose material.
These tests showed that the kind of vehicle they needed would be entirely determined by what kind of surface the moon had. But the answer to this question lay out of reach of even the most powerful telescope. NASA needed a closer look. It was only 4 years since the first satellites had gone into space, yet NASA's ambitious Ranger program was already being sent to the moon. These primitive lunar probes carried television cameras which would relay live pictures of the surface as they got closer and closer. But the moon was a difficult destination, and the first missions failed to achieve Earth orbit or missed the moon altogether. Then, in July 1964, after 6 unsuccessful attempts, a Ranger mission finally made it all the way to the moon with its cameras and transmitter intact. Lacking the ability to slow down, the spacecraft hurtled faster and faster toward the surface, sending back pictures until the final moment. But those last few seconds of flight brought the moon closer than ever before. NASA had finally proved they could get a spacecraft to the moon. The next step in understanding its surface better was to attempt a landing. The unmanned surveyor probe was designed to touch down gently in the soft lunar dust. At least, that was the plan.
When the surveyor landed, it bounced something like 10 feet in the air and then continued to bounce a few more bounces until it finally came to rest. And therefore, we realized that the lunar surface itself would probably have consisted of a very fine layer of upper layer and a very hard surface beneath it.
The Surveyor 3 mission proved that the moon's surface could support a wheeled exploration vehicle. Armed with these first direct measurements from the lunar surface, Ferenc Pavliks began locomotion tests on Earth.
We knew from the surveyor testing, wind-blown sand is very similar to what the lunar surface is covered with. And that's why we selected this sand dune area.
While Ferenc's wheel designs were still being put through their paces, the ever-visionary von Braun was already planning the exploration missions that a lunar rover might undertake.
So they came up with one concept, which was the Mobile Lunar Laboratory, or MOLAB, which was a pressurized cabin type of a system weighing about 8,000 pounds. And had the purpose of exploring the lunar surface over 2 weeks period of time.
The engineering companies came up with a variety of designs, but NASA wondered if astronauts could really survive for 2 weeks inside such a small mobile laboratory.
NASA was looking for volunteers, and I raised my hand. I was one of the 2 test subjects on that test. I was selected and made the commander. They kept us in there for a total of 18 days. We were good friends at the beginning of the test, but we weren't too friendly toward the end. We were getting on each other's nerves, to say the least. And we were very surprised when the lights came on and they said, the test is over, you can come out now. And as we walked out of MOLAB, there in front of us was not only our wives waiting for us, but Dr. Wernher von Braun was there too to congratulate us. And he referred to it as the can opening. We proved that we could live in that MOLAB for at least 18 days, and probably could have gone longer.
But the MOLAB trials also showed that a pressurized exploration vehicle would weigh at least 4 tons. And that meant a dedicated Saturn V launch to deliver it to the moon ahead of the astronauts. It would be hugely expensive. NASA started to have its doubts about von Braun's giant rover ideas.
It was becoming increasingly difficult to fund the projects that needed to be funded. And I felt that we'd taken on the job of going to the moon. We had not taken the job of traversing the moon, and on that basis slowed down the effort. I'm not quite sure whether I actually canceled it or not.
So eventually this MOLAB concept was dropped, and NASA sort of given up on putting vehicles on the moon. We were very disappointed, but there was nothing we could do about that.
It seemed that lunar rovers were destined to remain grounded on Earth, and the astronauts' exploration of the moon limited to a few short walks. But over at General Motors, there was one man who refused to take no for an answer.
We continued with General Motors money. We decided to look at smaller rovers. I decided that can be done, it should be done, we want to do it. We packed our bags and went to NASA headquarters, and we said, do you have any space for a rover? The lunar module descent stage had a triangular bay which was where they had instruments. And they said, well, that one triangular bay will not be used, so if you can fit a vehicle in this triangular bay, we might think about going again with a rover. So I said, my God, you want us to put a rover in a big piece of pie?
This piece of pie was a space to the right and below the lunar module's hatch. It was just 5 feet tall, 5 feet wide, and 5 feet deep. Not much bigger than the trunk of a station wagon.
So I called my very best engineer, Ferenc Pavlik, and said, Ferenc, here's what we have to work with. See what you can do. Sure enough, in less than a month, he had come up with a configuration that was very unique.
I decided to build a scale model. I like to build models. It was a family affair. My wife helped in making the seats, and I used the G.I. Joe toy of my 7-year-old son to be the astronaut.
Ferenc's new rover design was still twice as big as the space it needed to fit into. It was going to be quite a feat of origami to get it in.
We came up with an idea of folding it together. So first we had to fold the seats down. Then the end of the chassis was hinged and folded over 180 degrees. The forward chassis section was also hinged and folded over. Then the suspension linkage was designed such that folding in the wheels, they assumed a 90-degree angle. So this package now could fit into this triangular envelope at one corner of the lunar landing module.
And I said, Ferenc, we got to go to Huntsville and show Dr. von Braun what we have here.
So we proceeded to his office.
Knocked on the door, opened it.
And I guided this little model into his office. Now, he was at the telephone at the time. I looked at his face, and I saw just a great surprise.
He slammed the telephone down and says, what have we here? That gave us a great opportunity to explain to him what we had. We had already made a film. So we showed him a very short film on how it worked. We demonstrated to him.
So we spent as much as a half hour with him in discussing the concept. And he became very enthusiastic and supportive of the idea.
He said, we must do this.
I got a call when I was out of town one day from von Braun's office, and in that call, he asked me if I would consider taking the management of a new program that was given to Marshall called the Lunar Roving Vehicle Program. I said, what could a propulsion man possibly have to do with a car development? So I was very apprehensive about the whole thing. But on the other hand, you can't say no to a man like that when he asks you to take on a task that he has confidence in you doing.
With Von Braun's top engineer on the job, the dream of driving across the moon was back on track. Once more, NASA invited tenders for the contract to build a new lightweight lunar rover. And the General Motors team suddenly found they faced tough competition from Grumman Aerospace. Grumman was building the lunar module, which would carry the rover to the moon. If that wasn't enough of an advantage, they also had an innovative design.
A fundamental difference of the Grumman design was what we came to call the conical wheel. The cone shape itself did not permit dust and dirt and stones to anyway contaminate the operation of the wheel. It was highly innovative, and we were very proud of it. The Grumman thought is downstream. Damn it. Nobody's going to be happy with something that just is used for a couple of times, and you'll leave that $20 million piece of junk sitting there. Don't just go to the lunar surface, use it for a few days. Be able to hit a switch and turn it on and let Houston continue to run it out there. I mean, go down some craters you wouldn't have the guts to go down if it was manned.
Grumman's robotic rover was a strong contender. But was it enough to keep them in the running?
In the end, it boiled down to the deployment of the vehicle. General Motors did an outstanding job of being able to deploy that very, very easily.
First of all, you unfold it out.
General Motors' folding rover won the day. In July 1969, the contract to build the lunar vehicle was awarded to the team led by Sam Romano and Ferenc Pavliks.
They were both pretty outstanding individuals. They had this creativity and they had this air about them of confidence, and they made you feel like this product was ready to roll out the line right now.
When Ferenc showed me the solution he had, I was quite amazed. I said, Ferenc, I knew you could do it, and you did it. Good work, Ferenc.
July 1969. The crew of Apollo 11 has returned, the first men to walk on the moon. Around the world, crowds celebrate their achievement. But for a small group of automobile engineers, there was something else to celebrate: the chance to build a lunar rover.
We were celebrating the winning of the contract, but now we had to get down to work, and we had many, many challenges to overcome. One was the timing. We had 17 months to be ready for the Apollo 15 flight.
To help them deliver the rover in time, General Motors had teamed up with the giant aerospace company, Boeing. But even their rover project manager, Gene Cowart, thought the deadline was a little tight.
I really wondered about the length of time that we're given to do it, but I was told to make it happen as far as the engineering went, and that's what we did, night and day, it seemed like.
Ferenc and Sam already had a working miniature of their rover design, but now Boeing had to build it for real. And their toughest task was to make it light enough.
Descent to fuel only, no critical. He didn't want to say critical.
Every extra pound on the rover meant the LEM would burn more fuel as it descended to the moon.
From now on will be fuel.
Now the LEM, when it comes down over the moon, does not immediately just sit down. It hovers over the moon. It has to be able to traverse, looking for a place to land.
60 seconds. 60 seconds.
Each pound on the rover costs about 1/10 of a second in hover time.
30 seconds. 30 seconds.
Now, this is important because the more weight they have to carry, means that they're going to expend more fuel hovering.
Contact light.
Apollo 11 had landed with only seconds of fuel remaining. It was clearly vital that the rover be as light as possible.
We copy you down, Eagle.
The original goal was to have a rover that weighed 400 pounds. That meant that everything, we were counting ounces and tenths of ounces during the development program, because realize now the rover was an add-on to the basic lunar module.
And there were other challenges emerging as the first humans to walk on the moon returned with direct accounts of what the lunar dust was really like. It was more daunting news for the rover designers.
The astronauts quickly learned that the dust adhered to everything they touched. But it was a verbal description. We weren't sure what a wheel would do in it.
A novel kind of extraterrestrial tire was needed. The engineers had to reinvent the wheel.
We knew we couldn't use rubber tires because there's no atmosphere up there, and the rubber, it gets very hot and very cold. And secondly, if you had a flat, you were really in very bad shape. You couldn't get back. So we began looking at metal-type wheels. And we decided that we need to develop a metal wheel that was an analog of a tire. That is, it had the same characteristics of a tire. So we made a wire mesh and a cylinder. Then you take the ends of the cylinder and bring them around, you find that it becomes a wheel.
The outer surface was woven piano wire, hand-woven. The design of the mesh was such that when the wheel touched the surface, it could pick up soil. But as the wheel continued to rotate, the flex design of the wire would open up where it would clean itself.
We tested individual wheels in a soil bin facility. We could test the flotation of the wheel, the traction it could develop, and how much motion resistance had to be overcome, which was required to size the drive system, the motor, and so on.
Each wheel would be driven by its own separate electric motor sealed into the hub. These were powered by an array of batteries in boxes on the front of the rover.
We did not know the amount of energy it might take to drive a wheel through the lunar surface. If it rode on top of the surface, it'd probably take very little battery capacity. If it dug into the surface, it's like driving through mud. It would take a lot more energy.
Another problem for the battery team was temperature. If the batteries became too hot or too cold, the entire rover would stop working.
For the thermal control system, we were given a weight budget of 10 pounds. 10 pounds to do all the things we needed to do to keep the temperatures within bounds.
A conventional liquid cooling system with pumps and pipes was always going to weigh more than 10 pounds. Some ingenuity was required.
These boxes had a paraffin wax in there, and when the electronics components were generating heat during driving, the heat was stored in the wax, and it stayed at a fairly constant temperature during that melting process. Then, when the astronauts got through with the driving, they would open up covers over radiators. The radiators would reject the heat away, let the wax re-solidify, hence recycling it and making it ready for the next time they come out to drive.
Solutions like these helped to keep the weight of the rover down. But there was an even more critical problem: deployment.
The original design was going to use the springs on it for the thing to come out almost like a switchblade knife.
The astronaut just pull a little lever and everything would fold out for him. Well, they just never could get that to work.
We tried different things on this. We had a day to demonstrate that once, and all of the senior people came to see it.
They had a bunch of dignitaries there to watch this deployment. They pull the cable.
The thing went halfway and a loud crack and stopped. This gentleman who had very good English but a German accent, I remember saying,
"We will fix this."
And fixing it became a top priority. The entire success of the rover hinged on a reliable deployment.
If you can't get it up there, get it deployed onto the moon, it doesn't do you a whole lot of good to carry it up there if you can't get it deployed. And to be able to do it again and again, so it's dependable. The team then set about working long midnight hours and working to a process, developing a more phased deployment of the rover from that stowed up, folded configuration to get it out onto the moon in a dependable way.
We had to minimize the amount of work the astronauts had to do. And eventually we ended up with spring-loaded joints, which had to be released, and the spring automatically opened up.
It was very joyous occasion there for the engineers when they got it to unfold, because that was progressing along as being a real showstopper.
But it wasn't the rover that proved to be the showstopper for Apollo. On the 14th of April, 1970, the world woke up to the news that there'd been an explosion on board the Apollo 13 spacecraft. 3 astronauts were lost in space.
Apollo 13, this is recovery, over.
3 days after the explosion, everyone at Mission Control gathered to watch and wait for news that the Apollo 13 crew were safely back.
Odyssey Houston, standing by, over. Odyssey Houston, we show you on the mains. It really looks great.
Extremely loud applause as Apollo 13 on main chute comes through loud and clear on the television display here.
It was close. It was very close. So it's a real tribute to the whole system that they got out of that.
Apollo 13 had shown the world just how dangerous flying to the moon could be. The only justification for further missions was their scientific value.
Now scientists, geologists, were interested in areas farther away, like a canyon or a big crater or a foot of a mountain. And that could be done only with a roving vehicle.
It was the availability of the rover and the scientific exploration it promised that sent men back to the moon. With just a year to go before Apollo 15, GM rolled out their new test vehicle. Mission Commander Dave Scott would be the first to learn to drive it. The engineers called it their 1G trainer because it had been built to operate in Earth's as opposed to lunar gravity.
1G trainer was the apple of my eye. It was a real great machine. Trainer was to be used to train the astronauts to drive the vehicle. So this vehicle had to have the same configuration, the same performance as the rover.
The rover had both front and rear steering. Both would steer, they would steer at the same time. Or they could be disabled, the front or the back could be disabled. We did that for redundancy. If you turn both sets of wheels in the proper direction, it would turn around in its own radius. So it was very, very maneuverable.
Driving in Earth's gravity was fine, but it was important to experience the lighter feel of a drive in 1/6 gravity.
To achieve the 1/6 gravity as best you could here on Earth, you counterweighted this rover with cables. It seemed to just float across rocks, and it's sort of a giddy feeling, I thought. Well, you should have felt a heavy shock. It didn't. It just sort of went right over it with no particular problem. It was very strange to be suspended like that.
To keep an eye on the astronauts wherever they roamed across the moon, Mission Control decided they needed a mobile TV camera mounted on the rover. Adding new equipment to their already overweight vehicle was not something the engineers needed.
It was very difficult, stressful time. We worked late hours. We worked probably 16, 17 hours a day, and mostly Saturdays and sometimes Sundays.
You know, in all honesty, there weren't many light moments in the program. The only light moments I ever had was when I went home after work each day. It was just, every day was highly stressed. Every day was a new problem that we had to deal with, or a realization that perhaps we were not going to make a certain part of the schedule unless we did something different.
We didn't have anyone actually die, but we did have people get ill working on it because you were going at, you were with it night and day almost. I wouldn't want to undertake it again. I think I'd rather re-enlist before do this again.
Against the odds, on the 10th of March, 1971, Boeing and General Motors delivered the first mission-ready rover to NASA. It had taken 17 months of intense development.
We were elated that the system was ready for the deadline. And so it was a big occasion. We were extremely happy that we made it just by a day or two ahead of schedule. It was a great occasion to deliver the first vehicle for Apollo 15.
Out of sight and contact, stowed on board the LEM at the top of the Saturn V rocket, the engineers had no way of monitoring their rover. There was nothing left to do but cross their fingers and await the adventure that was about to unfold.
The day of the launch of the Apollo 15 was a very exciting day for me. As a matter of fact, my wife Margaret and I were also at the Cape and witnessing the launch. In a roar, a tremendous roar. I remember we were no more than several thousand yards from the launch. And the roar of the Saturn V actually made my chest vibrate. I felt the pounding on my chest, and I said, my God, this is exciting.
That was, you might say, our baby going up there now, and is everything going to go the way it should? Some of us who'd worked on this thing for years, it seemed like it was hard to believe, and yet away they went. But there's always that feeling when it gets to the moon, is it going to come out?
Dave, an extraordinary television picture here.
July 31st, 1971. Apollo 15 Commander Dave Scott steps onto the moon. His words echo the dreams of lunar exploration which had inspired Wernher von Braun and all the Apollo engineers.
Man must explore, and this is exploration at its greatest.
For the first time, Apollo astronauts were to travel miles from their lunar module, and for that they needed the rover. The engineers knew that the whole mission was riding on their design.
I was at Houston in the Mission Control Center. It was very tense.
Okay, Jim, let's take a look at our rover friend here.
Then the great day came, and we're all watching to see the rover come out, knowing that for all of the complexity of it, the rover coming out was a real meat in the coconut.
Okay, Jim, go ahead.
Now comes the big moment of deploying the rover.
Released. It's released.
They unlatched the cover to the compartment and then pulled a lanyard.
And it started coming out.
Bull, attaboy. A little more. Keep it taut.
The wheels flung open. Great elation on our part. It's coming out. And then the next step of the deployment, successful.
That looks good.
Finally, the whole vehicle was on the surface.
Man, this thing's nice and light.
So far, so good. But as Dave Scott and Jim Irwin began to check the rover's systems, they made a discovery that dismayed everyone at Mission Control.
I don't get much out of turning the
Okay, Dave.
Well, lo and behold, Dave Scott calls back and says, hey, the front wheel steering is not working.
Negative. But I don't have any front steering, Joe.
We thought, that goes 17 months down the drain.
Still no forward steering, Joe.
Roger.
Got another suggestion?
I was sitting in the Mission Control Center in the 3rd row. Dr. von Braun was in the 5th row. So when they said the front wheels are not steering, my God, I was very, very nervous. The back of my neck began to swell, get red. My ears were red.
It was a very tight spot.
Every second of the astronauts' moonwalk was precious. There simply wasn't time to fix the problem.
Jim, you can probably tell me if I got any rear steering.
Fortunately, the rover had been designed with 4-wheel steering, and the rear steering seemed fine. It would have to do.
Roger, Dave. Press on.
Okay, it's a good idea. Hey, Jim, I'm going to bring her around here and let's get on with it, okay?
Now, at last, for the rover engineers came the moment of truth. After everything it had been through, would the rover start?
We were sitting on needles to see what's going to happen.
Okay, Jim, here we go. Okay, Dave, we want a heading of 203. Okay, 203. Checkpoint 1. Gonna miss that double increment. I can see that now. Okay, we're moving forward, Joe.
Roger.
Ooh, hang on.
It had been just 10 years since the first human spaceflight, and now 2 astronauts were driving on another world.
Man, this is really a rock and rollin' ride, isn't it? Never been on a ride like this before. Oh, boy. I'm glad they got this great suspension system on this thing. Boy.
When I saw the rover working, it was the culmination of the dreams and the hard workmanship of the Boeing people, the General Motors people, and the Marshall Space Flight Center people that supported the program. And it was an awesome feeling to see that, and such a wonderful feeling, and so much relief that indeed we pulled it off. It happened. It was like winning a football game in the last 10 seconds.
Oh, this is really a sporty driving course. Man, oh man, what a Grand Prix this is.
It was the farthest any astronaut had ventured from the relative safety of the lunar module. But Mission Control was able to keep an eye on them thanks to the new improved TV camera mounted on the front of the rover.
Hey, Joe, the AGC says you ought to have a picture.
We've got a beautiful picture.
Flight Director Ed Fendel was operating it remotely.
The atmosphere in Mission Control on the first landing site, when we got there and took control of that camera, was absolutely crazy because everybody was looking at the displays up in the front of the room and they were watching this. It was amazing what people, I mean, it was like, holy mackerel, you know, this is going on. This is what we've really done. It was really quite wild.
For 3 days, the rover carried Dave Scott and Jim Irwin over 17 miles across the plains of Hadley on the most extraordinary geological field trip of all time.
Can you imagine that, Joe? Here sits this rock, and it's been here since before creatures roamed the sea on our little Earth.
There it is. And there it is, Houston. There's Camelot. Wow, target. I see it.
2 more rovers were flown to the moon on board the last Apollo missions, 16 and 17. In April 1972, the second rover transported explorers Charlie Duke and John Young across the Descartes Highlands.
That's 20 pounds of rocks. Oh, Tony, it's got some beautiful crystals in it, though.
They brought back 200 pounds of rock samples, which revolutionized our understanding of the moon's geology. And in December 1972, the third rover took Gene Cernan and geologist Jack Schmidt deep into the volcanic Taurus Littrow Valley.
Orange soil. It's all over. Orange.
Together, the three vehicles carried their crews safely across more than 56 miles of rugged lunar terrain. The discoveries they made helped scientists to reconstruct the earliest history of our Earth and its moon. And thanks to the mobile camera on the rover, as the astronauts climbed the mountains of the moon and traversed its plains, the rest of the world was able to explore along with them.
So the people here on Earth really were part of this mission. And I think it enhanced the whole human experience because, you know, we did do this, in a sense, for mankind. It was an astonishing achievement of mankind.
By the end of Apollo 17, Ed Fendell had captured over 50 hours of live TV from the surface of the moon. He now had one last chance to film something he'd been unsuccessfully trying to capture since Apollo 15, a lunar liftoff. The 6-second delay between pressing the buttons at Mission Control and seeing the results on his screen made this a difficult task.
On Apollo 15, we had some motor problems with the camera system.
What a ride, what a ride.
On Apollo 16, the lunar module flew out of the picture. On Apollo 17, what I was watching to get those pictures was a sheet of paper. And on that sheet of paper was time versus command. The command to tilt the camera up and to zoom out actually were transmitted before liftoff, so that when the lunar module started to move, the camera was already in operation.
3, 2, 1, ignition. Right away, Houston. Vector good.
Apollo 17's liftoff ended mankind's exploration of the moon. But the machines that took us there had done more than transport a couple of dozen Americans to the lunar surface. They had expanded the horizon of humanity. We were no longer an earthbound species. It was a profound step in the evolution of the human race. But for the 400,000 men and women involved in the Apollo program, it was simply the highlight of their lives.
Well, occasionally when I look at the moon, I can see 3 places where the rovers exist. I know they're there, and I feel good about them being there. And I'm sure that all the folks that worked on the rover and worked on the Apollo program feel the same way. It was quite an experience.
I feel like I was so fortunate to have been born when I was born and to have had the opportunities that I had to participate in mankind's greatest adventure. And it's with deep humility that I look back at those days and realize what an accomplishment it really was.
And as we leave the moon, and we leave as we came, and God willing, as we shall return, with peace and in hope.